So next we're going to move on to our panel, and I'll invite Chris Lloyd-Jones up for, he'll be moderating the panel, and then we have Stuart Harris, is that right? Stuart Harris from Red Badger, yes, we got him back there. We've got the lovely Mark over here. Hiran is somewhere, I saw him, there we go. Hiran Parak from Flexiscale, and Lesia Dimit, and I'm that roughly right, from Open Compute Project. If you guys wouldn't mind coming up, and Chris, I'll let you take the lead on this bit. We have a few microphones for you guys to share.
Hi folks, so my name is Chris Lloyd-Jones. As we're going to have a panel session on data centers, open technology, and the Patchwork Kilt, I'm just going to set a little bit of context about what Patchwork Kilt is. I know, Mark, you touched on it, and the other blueprints, and then we'll hand it right over to our panelists. So as we all know here today, Open UK is the UK organisation for open technology, open source, open data, open hardware. As part of our work on sustainability, we created a data center blueprint, or Patchwork Kilt, a couple of years ago. And the idea was we worked with public organizations, private organizations, NGOs, and governments to get an input into what the landscape of data centers and data center circularity was looking like. This is one of many different blueprints that we've now created, such as the EV charging blueprint, which can all be found today on GitHub. Earlier on today, we heard the announcement of a new hackathon between Open UK and the UN to use and build on these blueprints, which are now out of Google Slides and into a human-readable data format. A blueprint, according to Wiktionary, is a detailed technical drawing in some electronically storable and transmissible form. And for us, it's a roadmap. So that context set, without going too much into what the blueprints are, I'd like to ask each of the panelists to introduce themselves one by one. I want to start with Dr. Lesia.
Good afternoon, everyone. I'm Lesia. I'm representing Open Compute Project Foundation today. I'm super excited to be here with you and sharing some information about what we're doing and how we're doing. So Open Compute Project Foundation is a global community. It's a foundation that has more than 300 organizations. We have also more than 6,000 engineers and also decision makers who are volunteering, who work with us on deploying and developing open hardware for data centers, as well as other solutions. Within the OCP, I'm in charge of the Future Technologies Symposium, so these are the activities that are focused on identifying future opportunities and future innovations, and also the startup program. So these are the activities around innovations and potential opportunities for the data center industry that could be deployed within 2 or 4 years from now.
Thank you.
I won't talk anymore, I'll just say hello again.
Hi, I'm Stuart Harris, founder and chief scientist of Red Badger, which is a consultancy in London. About 100 odd people, some of them very odd, working with large enterprises, helping them build digital product. And in the process, leaving a legacy, upskilling and helping them understand, that sounds patronizing, it's not meant to be, new ways of working, new technologies, patterns and practices, etc. We're 13 years old, and we survived the pandemic, which is great, just. But I love what I do, but it's hard work because we're constantly dragging our clients kicking and screaming effectively into the modern world, and there's like lots of big challenges ahead, the biggest of which we've been talking about all day, which I'm obsessed with. And so I've been a software engineer for 35 years. My first job was in 1988. I've been around the block and seen all sorts of things, all sorts of messes, some of which I created myself. And I suppose actually now is an opportunity to repent of my sins and actually get involved in doing the opposite of that, which is like making really strong, reliable, efficient systems that don't consume anywhere near as much resource as you know. Somehow we've got into this state in the software industry where we think that compute resource is so abundant and so cheap. And, you know, the cloud has like fooled us into this situation where we can just use limitless amounts of storage. I mean, every time we take a photograph, and everyone takes a picture of the same thing, right? I was in Seattle last week. I went to the Chihuly Glass Museum. It's beautiful glass sculptures, absolutely breathtaking. And everyone's taking hundreds of photos of the, you know, and I think of all the thousands of people that walk past this take the same photos, and they all get stored in our phone. And, you know, I can look at photos of my phone from 15 years ago. They'll be there in 15 years' time, taking up all this storage and the compute, and it's just like crazy. So, and when we write software applications, we do exactly that. We just think we've got all the resource that we want. So I'm on a mission to change that.
Awesome.
Yeah, hello. Hi, my name's Aaron. I spent the last decade, let's say, in the cloud hosting space, well, previously with OVH Cloud, who have been doing a lot around actual water cooling, using it within their data centers for several years. More recently, I've been working as a freelance consultant and actually advising a couple of cool startups that are using what Mark very well explained is liquid immersion cooling. And that's a bit about me and my background.
So we've got an amazing set of panelists. I'm here as the moderator because Amanda's called me the grandiosely titled Chief Blueprints Officer, so I'm now looking after the Patchwork Kilt blueprint and the EV charging blueprint. But it's all about the panelists, so before we get into the harder questions, what I'd like to know from each of you is why you're passionate about open technology for sustainability, and Mark and Stuart, I know you touched on that, and what the turning point or the magic moment was for you, like why did you become passionate? So if we start at higher and just go back around.
Okay, so when I joined OVH Cloud, I think it was just very interesting to see the amount of open source integration that was done within the space, which I was not so familiar with at the time. And having recently joined or worked with OpenUK over the past couple of years and being more active, I'm actually more in a learning phase where I'm keen to learn a lot more. But the one turning point for me is this kind of community approach, collaborative, that everyone's willing to share their experience, to help each other, to really bring it so we're not sort of duplicating or replicating, as you say, increasing the amount of data and really sharing the good outputs everyone's doing. So I think that's the bit that inspires me to want to learn and know more.
Great.
I might probably answer this already, but the trigger for me, I think, was when the penny dropped in my head that all the goals align. Like it's almost like the faster your software is, the greener it's going to be, the more efficient it is, the more happier our users are going to be, and the greener it's going to be. The less data you move from the data center onto your browser, the faster your web page is going to load, the happier user's going to be happier, the planet's going to be happier. Or whatever you do, all the goals align. And I think that's really, really encouraging for me as well. So that's my trigger point when I realised that.
It's probably quite similar in as much as we didn't invent what we're doing, this idea of reusing the heat, but when you hear about it, you almost can't not see the logic of it. And I think when I was pitched it by a mate, we were trying to impress the chief exec of British Gas, and we said, well, what can we do? We were literally in a pub, and he said, well, there's this crazy, this was sort of 8 years ago, he says there's this crazy technology that you can dump computers in oil. So we bought a homebrew bucket and bought a load of massage oil, and we dumped a computer in it, and then we bought an Argos radiator and a fish pond pump, and we hooked this thing up to the radiator, and then when the chief exec of British Gas came into the room, we said, look, it's warm, and when you see it, it's so logical it's like all great ideas. Not that it's got anything to do with us of having the idea, but it's just I think in the environmental and sustainability movement more generally, I think we can all of us see most of the logic of it. We just need to now kind of get out of our own way, really.
Makes sense.
Me, I was always fascinated by the innovation and creativity. And when I say that, I mean how people can identify problems or see the opportunities for future development. So since I joined the Open Compute Project Foundation, I was really impressed by capacity of different individuals and organizations to have a conversation, to sit at the same table with your competitor or with your partner, and to talk about what are the current problems of the industry are, how can we solve them together, and what can we do, what kind of common efforts can we put together in order to build either the spec, either to a use case, either design fast, and so on. And then for me, the sustainability was just a progression of where our industry is heading, because once we achieve the maturity of the technology that we have on the market, we need to think, okay, what's next? And sustainability, solving the energy problems, carbon reduction, was just a natural progression of where our technology industry is and was at this moment. So right now we do work on different projects, including the sustainability, including the immersion cooling, including the circular economy. And these are efforts to make our, first of all, industry a better position and also help our societies, because we always need to think about the next wave of technological evolution.
I really liked your point there about frenemies and competitors working together in open source. I know that's something else we've heard today. So I've got a couple of questions I've prepared for each of you based upon your expertise. Hopefully you saw them. If not, they'll just catch you by surprise. We do have time at the end for the audience to ask questions too, so start thinking about what you might want to ask our experts as we get towards the end. If we go down some kind of path or segue, or you just want to comment, feel free to chime in. It's always better when we descend into some kind of organic discussion, dispute, etc. So I'm going to start with Stuart. So how do you see the intersection of open technology and sustainability? And with your love for Rust, what role does that play?
It's no secret that I love the Rust programming language. I'll tell you a little bit about why in a minute. But I think open source software is taking over the world, which is a great thing. The business that I run wouldn't exist without it. And one of the most magical things I think about it is that you can take a lot as long as you give back a bit, because software is free to duplicate. You can take, but you've got to give back. So we contribute actively to open source projects that we think that are useful. But there's two, actually, not just Rust, open source projects, which I really want to call out, because I think both of them are revolutions, and I don't use that word lightly. The first is Rust, which I think actually is really a revolution in software programming language design. And possibly the most important thing that's happened in not in living memory, in recent memory in the computer industry, and I'm serious about this. For the first time, we can have our cake and we can eat it with Rust. So before Rust, and these are my opinions, and don't at me, but you had to choose either performance or safety. So you could have performance with C and C++ and non-memory managed. You get lots of power. You're very close to the metal, but there's enough rope to hang yourself and lots of foot guns, and you can build very, very, very dangerous software that could even kill people in certain situations. Microsoft say that 70% of all the CVEs, the vulnerabilities in a lot of their software that's written in C and C++ are memory-related errors, which can't happen in memory-safe languages. So on the other hand, so if you don't choose performance, you choose safety, then you're going to program in a high-level language like Java or C# or JavaScript or Python. I mean, hundreds of them, right? But you pay the price of having a garbage collector that's cleaning up your rubbish after you and making sure that, really strong type systems in some cases, not JavaScript, that's a pile of rubbish, but there we go. strong type systems in places to protect you from making mistakes. And now for the first time with Rust, you can have both together. You don't have to choose anymore. You can have performance and memory safety, data safety from data races, fearless concurrency, all sorts of things that you would expect from high-level languages. And it is a high-level language. It was initially built for systems-level programming, like writing device drivers or whatever, or systems-level stuff, but it's actually rapidly becoming the best choice in lots and lots of different spaces, whether that's device drivers in the Linux kernel, which is starting to happen now, or whether it's embedded software on IoT devices, or whether it's operating system utilities, or whether it's high-level web applications, distributed web applications in the cloud. It's becoming a really, really good fit for all these spaces. Great for aerospace, for automotive software, all the places where safety and reliability is important. And it does this by pulling all the problems that you would not have later on and having them right at the front. So it has a very strict compiler that doesn't let all these classes of bugs get through. So what you end up building is something that's solid and reliable from the get-go, and it removes all the anxiety and the long tail of being called up at 2 o'clock in the morning on a Saturday morning when your users are having problems in production. So you don't get that. I mean, you can still write software with bugs in it, I'm not saying that. But the chances of whole classes of bugs, can't even get that far. Can't even get past the compilation phase. But the key thing and the relevant thing that's relevant to this this conference today is that it allows you to be really close to the metal. So you can be really performant and efficient, 100 times more efficient than high-level languages like Python or Ruby. And that means you can get 100 times as much work done for the same cost. And so if you're building 100 data centers, you might only need to build one. And so it can be really, really, really important because you get all the benefits. I mean, it's a perfect replacement for Java. And if you think about Java Spring Boot, which is quite heavy in containers, which are lighter than VMs, but still gigabytes in size potentially, running on VMs, running on metal. There's so much waste at each level, or you could just compile your application with Rust and have it take up 1 or 2 megabytes of memory and very, very little resource in terms of CPU, and you can pack much more work onto a server that way. So yeah, Rust. I'll talk about the other one later.
No, I like that.
Gone on enough.
It touches on a lot of the things that we had before lunch, from the comparison of program languages all the way through to how it can be a lot more lightweight.
Yeah.
So no, very good. Thank you.
It's sorry, I should just say that for 8 years running, it's been voted on developers' most favourite language on Stack Overflow annual survey, and there's a reason for that. And actually, all the things that enterprises care about: safety, cost, reliability, lack of bugs, all that kind of stuff. It has a great answer for that.
Yeah, and I know there's a lot of Rustaceans in the audience as well. So, Lesia, in your role overseeing innovation programs at the Open Compute Project Foundation, how do you see the Patchwork Kilt blueprint aligning with the future of open technology, if you do at all?
Yeah, I think it's really in line not only with the future technologies or our activities around innovation for the future, but also with overall activities of the OCP Foundation. So I'll try to keep some great information for the rest because I do have my presentation. But I just want to say that less than a year ago, we launched the sustainability as our fifth tenet, which actually confirms our commitment to the sustainability overall in our industry. So we do perform different projects, as I mentioned earlier, about the circularity, about the heat reuse, about the immersion cooling. And within the future technologies, we do have a technological track. So every year we are running the Future Technologies Symposium, which represents an event that showcases the future technologies and invites authors to submit their papers. So each year we have this data center sustainability track where people who work on different solutions, specifically those who are targeted the future long-term innovations, they can apply and showcase their technology within our symposium. We're also considering, for example, immersion cooling or data center sustainability as our potential future projects within the Future Technologies Initiative. So initiative is the longer projects where people from organizations can collaborate. So these are some of the activities that we do have within the OCP, either focused on current industry needs or on the future industry opportunities and challenges.
Okay, great, thank you very much. Haran, so given your role at OVH Cloud previously and your current advisory role at FlexiScale, how are data centers and cloud services evolving towards sustainability? What changes are you seeing take place?
Sure. So speaking first of OVH Cloud, so OVH Cloud for many years have been using water cooling, sort of directly on the chipset itself and extracting the heat this way, which is the most energy producing. And they've managed to create a lot of efficiencies by doing so. Not only that, but they also buy the components and produce the sachets in-house. So where typical, data center racks are vertical, these are horizontal, they're stacked 3 high, and therefore you get a higher density. So they've been taking different ways, because when you look at carbon footprint, a lot of it, when you look at traditional data centers, actually the plastic involved in the manufacturing of data centers, not only just the operation, but by building them and building those more open sachet servers, enabled them to gain those efficiencies, if you like. More recently, as I've been working with some of these, let's say, startups in the cloud space, which is FlexiScale, and there's another one out of India called Neve Cloud. And the next evolution, really, to deal with the use of AI or machine learning, as we talked about, the increase in compute, is actually using liquid immersion cooling, which is a lot what Mark talked about. And really, the advantages and what I'm learning is that there's average 40% cost saving on the deployment, so the actual capex that has to be invested is less. When we look at the energy efficiency as well, keeping the liquid in this immersion tank at an operate temperature means that there's 40% less energy, which is equally reducing the carbon footprint and increasing ROI. But also it takes, on average, 80% less space to run the same workload. So, let's say a 48U rack would do 50 kilowatts of cooling. In a single immersion cooling tank of 50U, so similar size, you can achieve 200 kilowatts of cooling. So comparatively, you can see the advantages or the advancement that's being made in this space, or the advantage of it. And particularly look at GPUs as well, the ability to be able to use them as an optimum performance and get 30% more processing power from those units with the thanks use of liquid cooling. So I think we can see some significant advances in this technology, if you like. And also there are other things about, we talked about the sustainability or the longevity of hardware, I think Gardu mentioned as well. And what we see is that because the components are fully immersed, they're less prone to spot failures or functional temperature increases. Therefore, they can run for a longer, and it eradicates mean time failure, so it gives a higher uptime. It means that the hardware has a longer life cycle as well, which is also impacting the carbon footprint as well. And the fact that it's modular, as you mentioned, it can sit in the corner of a warehouse or in a room. You can really sort of build it out and scale it and build this sort of edge network. And I guess one of the other innovations that we're seeing, particularly in FlexiScale and ongoing discussions, is not only what is done with the heat that comes out as you are, but what are the source of energy that comes in. And there are several sites across the UK and even Europe that are actually producing green energy and potentially, in most cases, selling back to the grid. Could it be an opportunity to place a data center modular setup close to such a site or on that site that is then actually being powered by green energy and not only outputting the heat or that's coming from it, but equally, powering this with green energy. So I think there are sort of great advancements that have been doing with liquid immersion cooling and how, really adding a green energy source can only add to the whole reduction of carbon footprint and being there. And I know that on FlixGirls we're looking at how they can engineer their own conversion, hyper-converged chassis to achieve even higher density to further reduce the carbon footprint. That's some of the changes.
So everything I've heard so far sounds really good. And Mark, your talk was also very positive. So what I'd like to know is why isn't the IT industry as a whole adopting these types of initiatives? Where are the adoption challenges? Why are we struggling?
Yeah, it's a good point. A lot of it's down to human brain chemistry. So a lot of it is just down to the fact that the data center industry has done what it's done very well and very effectively for 30 years. And whenever you're trying to change, what's the hardest thing to establish is a new habit, right? So I think a lot of it comes down to just habit. It's critical infrastructure as well. No one gets fired for doing the same thing that's been proved to work all the time. So I think a lot of it is that. The immersion cooling we love it, but it is messy, and there is another wave of technology that's going to mean that it's going to get much, much better. There are companies out there, at the moment, they're these bizarre sort of large tanks. They look like chest freezers, and the computers are in them, but there's like oil around. And then when you ask a data center expert, like this is the future, they all kind of look at you slightly quizzically. But already, when we first set up Deep Green, we imagined another Star Wars reference, sorry, but in Rogue One, where they hot swap, the plans just come out in a canister. That's already there for immersion cooling, so you don't have to mess around with the liquid. So I think a lot of it is just time. We think it's a generational shift. We've had this business for 7 years. We think it's going to take another 7 years to adopt. So I think a lot of it's patience. But we don't have a lot of time, so we have to balance that sort of that push for it. A lot of it also, a lot of it's the fact that reality is most data centers are stranded assets, right? If you can put the same amount of compute in 10% of the space, what the hell do you do with the other 4 halls in your enormous data center that's taken you 5 years to build? And there's no way you're ever going to get any more power in there. So it's not like you can fill up all of the rest of the data center with this amazingly compact, really efficient compute. We think you're going to have to cut the top off it and turn it into a vertical farm, because what else are you going to do with it? So there are structural issues to adopting this sort of stuff. We couldn't get arrested 7 years ago. I mean, we announced to Disney with great fanfare that we could render their movies on the hot water tanks, and they were like, "No fucking way, you're doing that." But now the industry is ready. So yeah.
Okay, you still made it positive at the end. So let's hear. What steps do you think organizations should take to integrate open technology into their sustainability agenda?
Yeah, I think each case for each particular organization would be different. But if we try to talk more or less in general, I would say that everything starts from the awareness, from understanding what are the needs and problems. And I do join you on the fact that the chemistry, the changing habits, and also actually the awareness of a problem would be the biggest challenge for most of the organizations. So once there is awareness, I think the next step would be, after awareness and curiosity, would be the experimentation. I think if more people will will become aware about the challenges around the sustainability, will become curious about how can they solve them within their own organization, they will go to the step 2, which is experiment. For example, the events like this could be really a great occasion to meet people, to learn from other organizations, to see what are the existing technologies, practices, and knowledge exist out there. And the third step would be adoption. So once you experience through different activities, through different other organizations, you can finally move towards adoption. Either technology, when the industry is ready, you can move towards adoption, or deployment, for example, deployment of open source hardware.
Okay, very good answer. I will be coming to the audience in just a second, so again, prepare your questions. So Stuart, what are your thoughts on the Patchwork Kilt blueprint for a carbon negative data center, and how could or should the software community contribute to that initiative?
I really can only speak for the software industry and the consumers of data centers and how to use them more efficiently. But what I do love about it is that it's we have to do all the things, right? Like we'll only ever achieve it by a little bit of everything. And so I like the fact that it addresses all sorts of different areas and issues. On the using less energy in the first place, so we need fewer data centers, I think we can do a lot as enterprise architects or whatever to build our distributed applications much more wisely, or with being conscious of the carbon footprint. For instance, I think today we've got into this habit over the last 10 years of building microservice applications that are massively horizontally scalable on Kubernetes. And the problem with this is that we have to, the pods that actually do the work, that contain the containers, that contain the programs that do the work, have to be scheduled, and they have to be scheduled effectively according to how much memory they need. Like a pod will request a certain amount of CPU, a certain amount of memory, and the scheduler will put them in the place where that's available. But 80% of those requests aren't actually being used. So, everything has headroom. The VM has headroom. The containers that are running on it have headroom. The JVM that's running inside the container has headroom. And so by the time you've added up all the headroom, we're actually not using anywhere near as much. We're not using our resources efficiently, basically, is what I'm trying to say. And so, your immersion probably works great for high-performance compute and things that are, GPUs and stuff that are busy all the time. But in enterprise applications, those machines might be idle for a lot of the time, and that's just wastage. We have to do something better about that. And this journey from VMs to containers isn't over by any stretch of the imagination, because we've got WebAssembly now has escaped the browser effectively, and it's been in browsers since 2017, and it's escaped the browser and now is actually really useful on the server as a deployment mechanism. It's a compile target. Rust and WebAssembly have a love affair because it's fun.
It's all about WASM.
It's all about WASM, and it literally is, because the great thing, VMs take minutes to start up, containers take seconds, unless they're running Spring Boot, they might take 40 seconds. Don't ask. And WebAssembly will start up in tens of microseconds. So now all of a sudden we don't get cold start on serverless, so a request comes in, we can start up the workload from nothing, do all the work, and then get completely out of the way, and releasing all the memory and all the resources back to other work. So that means we can much more densely, we can scale up. We've been scaling horizontally for so long that we don't think we can scale up, but we can get big machines now with a lot of capacity. We can scale up much more than we actually do, and maybe have our applications less distributed. Distributed applications cause all sorts of problems. As soon as you put a network between, you're introducing all sorts of issues, which we spend a lot of time and effort trying to work around. Well, maybe these things can actually be much closer together. WebAssembly has this new thing called the component model, which I think is going to change everything, because a program is written in a programming language, and usually just one programming language. Maybe we use some foreign function invocation or whatever to call something that's written in C. Python does this a lot for AI and stuff. But with WebAssembly components, each library could be written in a different programming language and run in a sandboxed way as part of a single executable. So now all of a sudden, all the ecosystems, which are very siloed at the moment, could collapse into one. Just imagine how incredible that would be, because like in the Rust ecosystem, there might be 10 or 20 HTTP or web servers, libraries or frameworks that you can use in your application. And there'll be similar numbers in all the other ecosystems, all that duplicated work. And humans do that, right? Humans actually write those things, and those humans eat and emit carbon.
Yeah, I quite like the references back to Gadu's talk on utilization earlier, and then what Annette mentioned about humans as well. Just want to make sure we got a chance to get to the audience. So Mark, it looked like you might have had something to add on the previous point.
Only that when you frame the problems of the data center world in energy terms, and you realize that actually want as much heat out as possible, as you say, running more efficient, running our assets so they're utilized 100% of the time from our point of view as energy folk, it's critically important. So all of these things are coming together, I think.
And then for Hiren, going back to the brain chemistry we talked about earlier, kind of humans doing what they've always done, what adoption challenges are you seeing for sustainable technologies, and how might they be addressed?
Absolutely. I think, as Mark highlighted, there's one, but I think the other is also perception that it could be costly to change. But in actual fact, when we look at some of the stats that I talked about before, that actually it's more cost efficient. But again, it's a perception, and it's going to be a change in attitude or culture, which will come over a period of time. I think the other big part is the interoperability or integration. So, how does one ensure that it does integrate, or how do people understand how it will integrate? And then it's the sort of skills gap or training required to then implement that change. And I think sometimes, do they have enough skills in-house within the organization? You mentioned liquid cooling, it's all new. How are we going to handle this? Which teams will be able to deliver that? So, the challenges there is about training, of course, or collaborating with other service providers that do understand. And then it's to say, well, if I'm going this way, am I being cost efficient because I'm investing on this side? And I think those are really some of the challenges that we see in terms of how people can really adopt and become efficient at it, which will come over a period of time. It's a learning phase, and I think each of those can be addressed.
Great. Any questions from the audience? Yep, just one question over there.
Hi, Mark. Just curious, when you're kind of distributing these data centers, breaking them down, perhaps having them under a swimming pool, how do you manage security?
Yeah, it's the first question everyone asks.
Probably was.
First, so we're building to tier 3 standards, so it's all N+1 resilient. There's 2 connections into 2 separate data centers, swipe card security across 3 portals, and all of that good stuff. But I think the interesting thought experiment, there's 2 answers to the question. Firstly, if we go to Stu's world and Rust, we don't need to fret about any of that, and that's the brilliant thing about it, because you can run your code on a Tesla's GPU, and that's already happening. But the other sort of thought experiment to conduct, and I have this conversation 4 times a day, is that if you think of an on-prem data center in a hospital, and it's tier 3 rated, we all go, okay, that's fine. And so actually, I think we've kind of got in our own way, in a way, with Deep Green, because we've said, we're doing this incredibly exciting, dangerous, really fun thing. And actually, all we're doing is building data centers with heat exchangers on. And so I think when you frame that for CTOs, and certainly in the last 6 months as we've done that, most people are just going, I get it, it's fine. They just send somebody around, they see the certification, it's just a data center. Yeah.
Any other questions? Yep, just over there, Sal.
So, for developers in the sustainability space, right, there's a lot of people that are wanting to get into this, for a lot of moral reasons and want to engage, technologists that have technical stacks. Increasingly, I think education is not something that we're talking about enough, right? Rust is great, and I can teach everyone Rust, but you still be remembering unsafe things and we're all screwed, right? So, do you have any recommendations to developers that are trying to get into the sustainability space? What do they need to know and understand, right? Architecture patterns, that kind of stuff. What are we missing in our engineering hiring space that you wish you saw?
Who wants to take that? Stuart, you look like you're getting into it. Stuart.
I can't agree with you more on the importance of it. I think it's our industry is a little bit weird in the sense that, most software engineers are self-taught, and there aren't any qualifications, and we're a weird bunch, and quite happy to program in our underpants in our bedroom for hundreds of thousands of pounds. No, it's crazy. And it has, I think we have to really, really concentrate on that, because there's a danger in my head, I think, of the industry almost like running off into the distance and leaving everybody behind, or leaving a lot of people behind. When we see this with our clients, big enterprise organizations that have the resources to run into the future with us, but not necessarily, I don't know, there's kind of some kind of institutional friction that stops them kind of moving, like walking through treacle or mineral oil or something. And I think our duty is to bring them along with us, and that involves writing about everything, talking about everything, and sharing as much as we possibly can all the time. I don't know what else there is.
Anyone else want to build on that? No. We've got time for one more question. Yep. Hello.
So I am the CIO in one of those very large banks with hundreds of thousands of developers, and we don't have enough developers in the industry, right? There's a chronic shortage, and we're still driving for last year, 100,000 engineers. Are we seeing, thinking about the pipeline through uni, etc.? I agree, lots of stuff, but you also have universities, apprenticeship schemes that drive towards some of the new software languages, because at the moment, I think it's sure to anyone in C, and I'm not suggesting go back to start coding in C, but the availability and the attractiveness of having that skill set, there's a reality of most developers will know what are the common skills and what will keep them in a salary. So I'm just wondering when it's happening kind of in the education industry to help drive that as well, because we need a pipeline.
I think Rust could actually help, because it would be an excellent teaching language, because with Rust you have to think more about how a computer really works. You have to know the difference between a stack and the heap, and where memory is, how it's owned and borrowed, and what happens under the skin. You do need a better sense of it, and it would make an excellent teaching language. And I think it probably will start to supplant some of those, and then we're in a different space altogether, because I think there's a lot of people that have fallen into JavaScript or something, or some really high-level language, and they don't really ever really need to know how a computer really works. And I think that those days should remain in the past. Let's move on from that.
Great. Anyone else want to add to that one? No? Okay, so we're now going to move on to your closing thoughts. I'd like to give you each a minute and a half each to give your final thoughts on what you'd like people to take away around sustainability and sustainable data centers. Alessia, do you want to start, kick us off? What do you want people to take away? I know you've got to talk, so.
Yeah. I think what you can take away is that be aware about the challenges around the sustainability. I'll be talking about the hardware. So Open Compute Project could be an option for you to get familiar with the open source, join the projects of your interest. We do have a number of different projects, either in development, in early incubation phase, or those projects that are already deployed on the market. So to really get yourself familiar with what we do, what can we propose. If you're a startup, you can also reach out to us and participate in our program. So our organization proposed multiple opportunities for those who would want to join us and solve some of these sustainability problems, because there are a lot of them, and I think if we put our common efforts, including through the willingness of education and increasing the awareness about the existing knowledge and databases, together we can go faster and solve these problems better.
I'm not fully doing it justice, but that common theme of cooperation, I like it. Okay, Mark.
I'm going to sell for a minute because for me it's all about starting. As I said, I think we let perfect get in the way of good sometimes, and I guess you'd expect me to say it, but actually, we've seen an incredible number of people come to us in the last 6 months, and a lot of people are starting to give us workloads. So if you can start. And like we've all said, when sustainability and sustainable solutions are cheaper, faster, and greener, then why wouldn't you? And I think if you don't start using different programming languages, if you don't start using different technologies, if you don't start using different data centers, you are going to be left behind, because your competitors, your competitors are going to have an advantage over you. So start.
I wasn't even that salesy. That was great. Okay, right, Stuart.
I just want to say computers are really fast, like incredibly fast. Who knew how fast they're going to be? Apple, the A17 chip on the iPhone 15 was 35 trillion operations per second or something ridiculous on a mobile phone. I mean, we've made them slow by putting layer on top of layer on top of layer on top of layer on top of layer. And it just turns out that if we get a bit closer to the metal, we've got the tools now. Tools like Rust give us all the more. We can build better quality software that is cheaper to build, cheaper to run, cheaper to maintain, and more efficient. It's got all the things we want. Much closer to the metal, we don't need all these big layers. So I think the future is actually very, very bright in terms of being able to reduce the amount of carbon that we emit.
Nice, thank you. And Hiram.
No, I think Elsie mentioned a point earlier as well, of test and adopt, and I think it is that point where the adoption needs to accelerate, and until people do get the confidence to test and adopt, I think we'll remain in a world that moves slower. But actually, the world is moving faster if you think about it, and absolutely, as also Mark mentioned, it is the time to change and look at that. Many companies are more and more vigilant of the sustainability efforts that everyone's making, and I think this space in particular does need to advance in this way and adopt these new technologies that provide greater efficiencies compared to how things have been done historically.
So I'm trying to summarize that as cooperate, the economics are there, don't build on bloatware, and it's time to adopt. Let's give a hand to our panelists. Thank you very much.